So in this video we're going to look at the effect of changes in pressure on the position of equilibrium. We're going to have a think about what Le Chatelier's principle, how it can be applied to changes in pressure. So what we know about pressure is that pressure is caused by particles banging on the sides of the container. So the more particles there are in the container, the greater the pressure will be, and the fewer particles there are in the container, the lower the pressure will be. So this pressure thing is only going to be relevant to gas particles that are moving around, so we're only going to be looking at gases, and we'll be looking at their effect on the pressure inside the container. So I'm just going to use this ammonia example for a second and just have a look at it in a bit more detail. So if we have a box of the same volume and we only had the nitrogen and the hydrogen in there, there'd be 4 moles of particles. That's actually lots more than 4, but I just can't draw that many. 4 moles of particles in there. If we only had ammonia in there, we'd have 2 moles of ammonia from the balanced equation. Which side of those is at higher pressure? So we can see that there's more moles here, so that equals more pressure. There's more pressure on this side. Now in reality we've got to remember that we're somewhere in the middle and we've got a mixture of all of this, but if we shift left we will create more moles. If we shift right we'll create fewer moles. So one of the things we're going to have to do all the time is decide which side has the most moles. Because fewer moles is least pressure. Okay, so more pressure on the left, less pressure on the right. And remember, we're going to do whatever we can to oppose the change. So if I were to try increasing the pressure, so if I was to increase the pressure, then I'm going to want to try to shift to the side that decreases it, and this side is least pressure, so I'm going to shift this way. Whereas if I were to decrease the pressure, then I want to shift to the side that will create some pressure, so I'm going to shift this way to the left to create more pressure. So effect of pressure on gaseous equilibriums. So my top tip, step 1, is count the number of moles on each side. So on this side we have got 1 add 3 is 4 moles in total, 4 gaseous moles in total. On this side we've just got the 2, so we've got 2 gaseous moles. So which side is at higher pressure? This side is a higher pressure, this side is a lower pressure, because more moles exert more pressure. So how would we answer our little gaps? There are fewer moles of gas on the right-hand side. So if the total pressure is increased, according to Le Chatelier's principle, we've got to try to do the opposite and decrease. So if the total pressure is increased, equilibrium is going to shift to the right to oppose the change. Why does shifting right oppose the change? Well, it opposes the change because there's fewer moles and so a lower pressure. What would happen to the amount of ammonia we produce? We call that the yield. And our yield of ammonia would increase. So increasing the pressure increases our yield. This is something we would like to do. Right, take a look at this second example and see if you can work through it in the same way. So start off by identifying which side is at higher and lower pressure. So check your answer. Did you get that? And did you explain why shifting left opposed the change? We've got one final example. See if you can spot what's different about our final example. So in this example there was the same number of moles on each side. So changing the pressure, whether you increased it or decreased it, wasn't going to affect your yield. There is a little note there at the bottom that's really important to pay attention to. An increase in pressure always increases the rate. Didn't want that to be in that orange colour. An increase in pressure always increases the rate. Okay, because there are more particles per unit volume, so more collisions per unit time. So we're going to always get it going faster, which is another consideration a chemist has to take. We want it to be fast, but we also want it to give good yield. So we're often having to do a compromise, and you might have talked about that at GCSE.